Okay. Now coming to the next type of checkpointing and recovery algorithm, which is said to be asynchronous checkpointing and recovery. Right? Asynchronous checkpointing and recovery was proposed by Jaung Venkatesan. So it's also called as Jaung Venkatesan algorithm. Here there are some assumptions as usual. The communication channels are reliable, delivery of message in FIFO order, infinite buffering, message transmission delay is arbitrary, but not finite, but finite, right? It is arbitrary means delay will happen. Sometimes the delay will short and delay will be long, or it happens at one particular time and happens at another particular time. We cannot say it is arbitrary, but it is finite. Finite number of delay only happens. So these and all are assumptions made by this algorithm, Jaung Venkatesan algorithm. Okay, and the underlying computation, otherwise the application, is event driven, right? That means the process P is at state S, receives message M, processes the message, moves to state S dash. Okay, so this is what event driven. So process is changing state to state. If it's yes, it's in yes, sending message. After that, it becomes S dash. Okay. Okay. So this is what actually the event driven. So that the process, every process is denoted as a triplet. Here the triplet S, M, message send, which represents the state of any process P. Okay. So here S denotes the state, M denotes the message, and message sent denotes the content of the message. And two types of log storage are maintained. One is volatile log. Volatile means we already know it will vanish after some time. Okay, so this is a short time to access, but lost if processor crashes, right? And if at all it moved to the stable log periodically. Okay, it's a temporary log. And there is a stable log also, which is kept for longer time, even though the processor get crashed, right? Okay. So these are the basics you have to know before getting into the Jaung Venkatesan algorithm. And here the checkpointing is asynchronous, right? Asynchronous means there is no cooperation. That is, in the previous case, it's synchronous because all the processes are cooperating for a time, right? They will be obedient and take decision at a time, isn't so? By that decision taking duration, they won't be allowed to send any message or something else. It is a common room meeting, right? But asynchronous checkpointing is not like that. Asynchronously, the processes are not being controlled, right? So after executing an event, the triplet is recorded, right? Without any synchronization with other processes. That means a process whenever it necessary, it's free, or otherwise arbitrarily they may log the triplet, right? And there is a local checkpoint consists of a set of records, right? First are stored in volatiles to log, then moved to stable storage, right? Okay. And this recovery algorithm. So let us first learn the notations and idea used behind the recovery. Here the notation called RCVD, which is received in the received of I from J, received I from J, right? Where J at the point of checkpoint, local checkpoint, CKPTI is the local checkpoint of the process I, right? So received of I, process I from J at the local checkpoint will be the number of messages received by PI from PJ from the beginning of the computation of the checkpoint of CKPTI. Okay. And what is sent, this message is sent I to J CKPTI, at the time of CKPTI, is referred to the number of messages sent by PI to PJ. That is very, very important. This confusion is PA from PI from PJ. In reverse, PI to PJ. Right? It received and sent. Okay. There are two processes involved here, PI and PJ. Okay. So here, sent and received. Okay. This is what the scenario, right? So the number of messages sent by PI to PJ from the beginning of the computation at checkpoint CKPTI, right? At particular checkpoint, how many messages are received from PJ to PI? Similarly, how many messages are sent to PJ from PI, right? So this is what the notation. And another idea here is, from the set of checkpoints, find consistent among them. Find a set of consistent points. Doing that based on the number of messages sent and received. That's the idea, right? Now this is the algorithm. Algorithm paathukonga. Example sollambodhu puriyum. Algorithm is also simple. Here, the procedure for rollback recovery, processor PI executes the following, right? So PI, processor PI executes. First is step A. This is the step A and this is the step B. During step A, what happens is, if processor PI is recovering from a failure, processor PI happens to fail. It recovers from its failure. Then what it does is, it takes the local checkpoint CKPTI. Okay, so this CKPTI will be obtained by referring to the latest event, because there is a log used, no, stable log, volatile log, and the log poi paako. So latest event logged in the stable storage, right? So the stable storage only can able to serve because it is permanent. Volatile storage, once after the crash occurs, it vanishes. So here the log details are available in stable storage. So with referring the stable storage log, the process PI can obtain the checkpoint where, that is before crash, what was the state? CKPTI, that is what CKPTI. Otherwise, else CKPTI will be. Okay, suppose the processor PI recovering after failure na CKPTI stable storage la irundhu edukum. Otherwise enna pannum, latest event that took place in PI, the very latest event. Okay, it is either in stable storage or in volatile, because it doesn't happen, a failure doesn't happen in this case. So volatile storage paadale theriyum, right? So there is a process PI. Here at failure occur. So at this particular stage, the event checkpoint will be logged into storage. So once after failure, when it crash occurs and recovery happens here, the process come and refer. This PTI is learnt. It comes to know what is CKPTI. Then it's the process get into step B. In step B, for k is equal to 1 to n, where n is the number of other processors involved in the system, right? Okay, for example, there are 3 processes, P1, P2, P3, n is equal to 3. Okay, for every process, for each neighboring process, every other process, or process, for example, PI start pannuduna, for example, there are 3 processes. If P1 start, it takes P2 and P3 also. For each neighboring processor, PJ, do computing how many messages are sent from the checkpoint CKPTI, right? So, for example, in this case, if suppose P1 starts, okay, if there are other processes like P2, P3, now P1 starts Suppose P1 sends message here and here. Now this is the CKPTI, right? And here P2 have sent already a message. Yeah, this is the scenario. P1 has sent 2 messages, P2 has sent 1 message, right? Now computing send of I to j at CKPTI. How many messages here? 2. I to j means here P1 is I, P2 is j, right? So because we are talking from P1, so all the neighboring nodes here, the Pi here is, the K here is 1, so it is P1. அப்போ other process என்னன்னாங்க இருக்கு? P2, P3 ரெண்டையும் பார்க்கணும் இல்லையா? Now sent of I to j, what is sent of 1 to 2 at CKPTI? How much? It is 2. Then sent of 1 to 3 at CKPTI equal to 0 because there is no message transfer between P1 and P3, right? Okay. Send a rollback. After computing this send command, it then send a rollback message, right? Rollback of I comma sent of I to j CKPTI message to PJ, right? இப்போ இந்த 3 மெசேஜையுமே சரி இந்த 2 மெசேஜையும் ரோல் பேக் பண்ணணும். ஓகே, இதை ரோல் பேக் பண்ணணும், இதை ரோல் பேக் பண்ணணும். பட் இங்க ஒண்ணும் இல்ல கம்யூனிகேஷன். ஓகே, ரோல் பேக் end for. Similarly, when so this happens, so for the first time this for loop is executing for each neighboring processor. First the neighboring process is taken as P2, send a rollback. Next the neighboring processors taken as P3, send calculate send and rollback. Now the algorithm ends இல்லையா? இந்த for loop end ஆயிடும். இந்த மாதிரி send rollback பண்ணோனே இந்த for loop end ஆயிடும், right? Now what happens is for every rollback j comma c, right? Message received from a neighbor j, right? Rollback of j comma c, right? So in the case la rollback of I comma send of I to j CKPTI nu போட்டுருக்கோம். Of what is I, which is I is 1, P1 layer, that's what I is 1. What is sent of I to j CKPTI? Here sent of I to j 1 to 2 CKPTI is 2, so 1 comma 2. Rollback of 1 comma 2. Okay, so P1 sends a rollback message of 1 comma 2 to P2. Okay, so that's what the rollback message or content. Now for every rollback j comma c, adina enna artham? Rollback j comma c, this is j, this is c, right? Received from the neighbor j. At the receiver end, what happens? If received of CKPTI, for send receiver here is j, which is P2. At the P2 ending, P1 end la idu nadakudhu. P2 end la it calculate received message. What is RCVD of received of I from j to I இல்லையா? What is received of j to I at the point CKPTI? At point CKPTI, j received 2 messages, isn't so? 2 messages. So it is 2, right? This happens if received of j from j to I, received of I to j is CKPTI is greater than c. So it seems to be an ARPAN message. Seems to be an ARPAN message, right? For example, before this checkpoint only 2 messages sent. After checkpoint 1 அனுப்பியிருக்கிறோம். But at the count of P2 it is 3. So these two messages only P1 remembers and sends rollback of 1, 2. But for this message, there is nothing calculated because this message, the parent is not accounting since it is roll recovered. So that always here this condition satisfied, received of CKPTI is more than C, right? That is the rollback sola panna vendiya message and message, right? Then find the latest event E such that received of E equal to C. Okay, adukku mun event E may be the volatile storage or so maybe in the volatile storage or in the stable storage. So by taking that previous E, the checkpoint of the jth process will be changed. The checkpoint of this jth process is changed. So P1 inge check, the processor understands that there is an orphan message and finds the nearest checkpoint, this previous checkpoint, which is called the event E, latest event E, with refer to the stable storage or volatile storage. So the checkpoint of the process, second process, is rewinded to the previous location, right? So this is how actually, P1 க்கு முடிச்சாச்சு. But next, இதே same process, K is equal to 2 ஆகும்போது, now P2 starts. P2 starts sending message. How many it has sent to P1 and P3. Similarly, it has to roll back. Then P1 and P3 are checking whether it is right or wrong. If it is right, roll back பண்ணிடும். Wrong இருந்தா next event கண்டுபிடிச்சு, latest event கண்டுபிடிச்சு roll back பண்ணும். Right? So this is how actually, and then once completely it is over, then P3, the turn comes to P3. Okay? So this is how actually rollback recovery algorithm works. The example. This is the example. There are three processes. What we said is X, Y, Z. Here, X, Y, Z, X sends a message at EXO to YA. Similarly, X receives a message EX1 from Y. Then Y sends message to Z at the same time. And Z sends a message. So you look at here, these are the messages communicated, message transactions, right? Now, let's assume a situation where here the failure occurs at Y. Y fails and recover from Y1. Y fails and it recover from, this is the recovery point of Y, right? So now, as per our algorithm, right? Since Y recover from here, it has to refer the log, stable log, which is the latest event EY2. Leya? So EY2 la irundhu Y restart பண்ணும். With the EY2 la enna state ங்கிறத log la irundhu வாங்கிட்டு Y1 stage la recover ஆகும். Okay. Now, as per our algorithm, the checkpoints has to be set, no? X, Y, Z are setting CKPTX as EX3 because X do not fail, right? While the algorithm asking for taking checkpoint, which one is the latest event at X inge. So this may be the checkpoint of CKPTX. And Y here, EY2 la எடுத்துக்குது இல்லையா? So here EY2 is the checkpoint, CKPTY. And Z will take checkpoint here. E Z2 CKPT Z. Okay, good, checkpoint eduthachu. Now coming to the iteration 1, which is given to the turn for X, right? Iteration 1 here, K is equal to 1 to 3 because N is equal to 3 here. Here there are 3 number of processes. So K is equal to 1 to 3. Now K is equal to 1 means X, right? Now, இப்போ என்ன பண்ணோம்? இந்த X, Y, X will calculate send, number of send, right? X will calculate number of send and send a rollback message, right? So X calculate பண்ணனும் for number of sends. How many send are there at this point? CKP with reference to CKPTX. Send of X to Y is 1, 2. Send of X to Y is 2. Right? Send of X to Y at the point EX3. EX3 is equal to how much? 1 and 2. And send of X to Z. X to Z at point EX3 is equal to, is there any, yeah, 1. Here, EX2 lerundu inga oru message varudhu. So this is 1. Then what will happen? Send of X to Y at EX3 is 2 and send of X to Z at EX3 is 0. So X sends rollback message of X comma 2, right? X comma 2 to Y and rollback of X comma 0 to Z. Please, idha neenga ipo paakadinga, ipo vendam, right? Rollback of X to 2, X comma 2, rollback of X comma 0. Okay, move on here, right? But now, on receiving the rollback message, here from X, rollback of X comma 2 to Y. That's similarly rollback of X comma 0 to Z ku anipirchu. Now on receiving this rollback message at Y, what happens paakalam, right? Now at Y, the received from X's, right? Received from X is calculated, right? At Y, received of X from X is X at EX3 equal to, right? At this particular point, there is only one message from X. So 1. Now what happens? The received of X comma 2 is greater than received Y at X, right? Then what happens now? According to the algorithm, when it is greater, the checkpoint has been revised at X. So EX3 ku badala, now find the latest event for which it is matched, right? So which is EX2. EX3 la irundhu paakumbodhu dhaan the difference irukku. So E is equal to EX2. Now X change its checkpoint to EX2. Okay. After receiving this rollback message from X comma 0 from X, Z will also calculate how many messages it received, right? Yes, Z received 0 message. So received is equal to rollback. So okay, rollback pannikonga, right? Okay, this rollback will be accepted. Okay, so similarly, Y will start doing and referring how many messages sent and received to other processes and roll back accordingly. Okay, so similarly it happens. Okay, so X will be rolled back at EX2. Okay, Z will here EZ2 la வெச்சு பார்க்கும்போது Y வந்து 2 மெசேஜ் அனுப்புனதா கணக்குல இருக்கும். பட் இங்க இருந்து பார்த்தா ஒரு மெசேஜ் தான் Y ல கணக்குல இருக்கும். சோ என்ன பண்ணிடும், Z இந்த பாயிண்ட்ல EZ22 க்கு பதிலா EZ21 ல வைண்ட் அப் ஆகும். இதோட this is the present checkpoint, sorry, existing. Now this is the new checkpoint, right? So with reference to Y's failure, X rollback at EX2 and Z rollback at EZ1. Recover at E is at 1. Okay, abdi recover ana algorithm correct. Okay, there is no problem at all. No ARPAN message, no last message, and all. So now what is the consistent set of checkpoint identified out of the algorithm? EX2, EY2, and E is at 1. This is the consistent set of checkpoint identified by the algorithm. So this is like this. Okay. Okay, this is the point where the consistency we can obtain. So that recover at this point happens to recover from failure without any losses, right? Okay, this is what actually the algorithm works.